Hello and welcome to Call of Chemistry. We are starting the first chapter of class 11, that is some basic concepts of chemistry. I am expecting to complete the chapter by 4-5 separate videos and I hope you guys like that. So in this video we will discuss about significant figures and rounding off. So let's start. Significant figures basically the minimum number of digits are required to express a value of scientific notation without loss of accuracy. There are some rules to determine significant figures in a numerical expression. What are they? Rule number 1 says all non-zero digits are significant. Example, 173 centimeter, sorry, 0.173 centimeter and 1.73 centimeter. All are non-zero digits and therefore three significant figures. Rule number 2 says all initial zeros are not significant. Example, 0.173 centimeter. Here, this is the initial zero, so this is insignificant. So here, three significant figures. Similarly, these two zeros are initial zeros. So there are also three significant figures. Now, what rule number 3 says? Zeros between two non-zero digit are significant. For example, here how many significants are there? So these are initial zeros, so these are not significant, and these two zeros are between two non-zero digits, so these all four digits are significant. These all four digits are significance. So rule number 4 says zeros at the end or right of a number are significant if they are on the right side of decimal point. For example, This has three significant figures. As these two zeros are followed by a decimal point, so these all three digits are significant. But if the terminal but the terminal zeros are not significant if there is no decimal point. For example, 400. How many significant figures are there? According to this rule, there are only one significant figure, as these two zeros are terminal zero and there is no decimal point, so here only one significant figure. And rule number 5 says exact numbers have an infinite number of significant figures. Suppose 40 pence, we can write that 40.00000 and so on. So there are infinite number of significant figures are there. The ambiguity in the last point can be removed by expressing the number in scientific notation. What does it mean? Suppose 4500 meter, and we can express it in 2 or 3 or 4 significant figures. How can we? That is 4.5 into 10 cube meter, or 4.50 into 10 cube meter, or 500 into 10 cube meter. This has two significant figures. This has three significant figures, and this has 1 2 3 4 4 significant figures. Now sometimes the final result of a calculation contains figures that are not significant. Under such cases, the final result is rounded off. So basically, rounding off is a process by which digits are dropped with or without minor changes in the figures retained. One could keep following points in mind for rounding off the number. So there are some rules for rounding off. What are they? If the rightmost digit to be removed is more than 5, then the preceding digit will be increased by 1. Suppose 58.87. This digit contains 4 significant figures, and we have to, if one asked that, we have to express this digit into 3 significant figures. Then we have 58.8, but the 7 that is removed is greater than 1, greater than 5. So the preceding digit, that is 8, will be increased by 1, that is 58.9. That is rounded off result. Rule number 2 says, if the rightmost digit to be removed is less than 5, then the preceding digit remains unchanged. Example, 58.82. We have to express in 3 significant figures. Then the last digit to be removed is 2, which is less than 5. And hence this 8 remains unchanged, and the rounded result would be this. Significant figures. Now rule number 3 depicts if the rightmost digit to be removed is 5, then the preceding digit is not changed if it is an even number. Example, 5.25. If we express this whole system into 2 significant figures, then the rightmost digit to be removed is 5, and the preceding digit is 2, which is an even number. So this is not changed. This is the rounded result. In 2 significant figures, and the preceding number is increased by 1 if it is an odd number. Example, 5.35. If we have to retain this figure into 2 significant figure, then the rightmost digit to be removed is 5, and the preceding number is 3, which is an odd number. So we will increase by 1, 5.4, which is the rounded off result. In 2 significant figures. So addition and subtraction of significant figures, the next topic. We'll understand this by some examples. Suppose 35.65 plus 185.262 plus 65.1. We have to add these three figures and we have to reach the result to the accurate significant figures in terms of accurate significant figures. So the result is 286.012 and we have to round off this whole system in terms of accurate significant figures. So the rule of thumb says the smallest number of decimal places would be retained in the rounded off result. So here the smallest number of decimal place is 1. Here it is 3, here it is 2. This is the smallest number of decimal place. So the rounded off result would be 0.0 because we have to retain in result the same smallest number decimal place with the same here, that is 1. There here also is 1. So it is the rounded off result. Another example, suppose 2.432 into 10 to the power 6 plus 6.512 into 10 to the power 4 minus 1.227 into 10 to the power 5. So here the rule of thumb says we have to reach to the final rounded off result and we have to retain in terms of some higher power of the 10. So here the higher power of 10 is 10 to the power 6. This is higher power and we have to arrange the all three systems in terms of this higher power, that is 2.432 into 10 to the power 6 plus this term would be 0.06512 into 10 to the power 6 and this term would be 0.1227 into 10 to the power 6 and the result is 2.37442 into 10 to the power 6. Now here we see that all these are contains 4 significant figures. This is 1, 2, 3, 4. This also 4. This also 4 significant figures. So here we have to write this as 4 significant figures. So for the rounded result would be 2.374 into 10 to the power 6. That is rounded result. Now how how multiplications and divisions are carried out in terms of significant figures. Suppose 0.12 into 9.67 8234 upon 0.0178. The rule of thumb says the final result would contain the smallest number of significant digit as here contains. So here the smallest number of significant digit is this, that is 2. That is 2 is the smallest number of significant digits. So here if we get the result, then we have to round off this whole system into 2 significant figures, that is 65. So that is the rules of multiplication and division for significant figures. So by here I am stopping this. If you have any doubt, please let me know in the comment section. Please like, comment and share. my channel and subscribe my channel. Thank you.